Welcome to Forces Pro, an easy-to-use tool for development and deployment of predictive controllers. Before Forces Pro was available, one would first need to figure out how to formulate a particular control problem mathematically. This typically required reading complicated research papers that are hard to understand. Then you would need to choose some optimization software for prototyping and tuning and integration with your simulation environment. If the solver performance was not enough, which is often the case, you would have to look for alternative software, which typically comes from poorly documented research projects. Worst comes to worst, you might have had to code it yourself, and this would easily have taken months of development, even for a specialist engineer. Luckily, now you can use Forces Pro to automate the whole process. Define your control problem in a very intuitive way. Generate prototype controllers for simulation in MATLAB Simulink in under 5 minutes. And once you are happy with the control behavior, generate high-performance deployment code from a wide range of state-of-the-art methods that are automatically customized to your particular problem for extra performance, saving you time and improving the control quality. Now let's see how we can use Forces Pro to quickly prototype an optimal controller for an unstable F-16 fighter jet. We have a simple 4-state model with 2 actuators, and we would like to track the references given by the pilot as fast as possible, while satisfying constraints on the actuators and outputs. You can download the model of the aircraft from embotech.com by clicking here. We want a high-performance controller that will operate the aircraft on the system limits optimally. This is very hard to achieve with any other control technology. Here we have a simulink diagram that we are going to use to simulate the controller. We have the plant, which in this case has the same aircraft model as the controller. I will also be feeding in some references simulating an aggressive maneuver. To start my controller design, I'm just going to paste in the Forces Pro Simulink block, give it a name, and I double-click to open the configuration dialog. First, I need to input the details of my discrete time model. On the workspace, I have several matrices describing a state space model for the aircraft, which I type into the appropriate entries. As the control objective, we want to track an external reference, and this is going to be provided as an output reference. Forces Pro will automatically compute offset-free references for the states and inputs, so you don't have to worry. We are going to choose a prediction horizon of 5 steps. You can make this arbitrary long, but 5 steps will be enough in this case. And then I want to define my objectives. I am mainly interested in tracking my 2 outputs as fast as possible, so I will make those objectives 10,000 times more important than minimizing the use of my actuators, which in this case are the flaperons and elevators. We also have some output and input constraints. We want the angle of attack to be between -0.5 and 0.5 degrees, and the pitch angle to remain between -100 and 100 degrees. Since we are going to operate the aircraft at its limits, we want these constraints to be soft to prevent any infeasibility problems. For the actuator constraints, the elevator and flaperon angles cannot exceed 25 degrees in each direction. In this example, we don't have constraints on the actuator slew rates, but we could also include them if we needed to. Finally, we are going to build an output feedback controller. So we will tell Forces Pro to build an estimator for us. We will use the default options. Now that we have finished configuring our controller, we can generate a controller for prototyping by typing configure block on the MATLAB command prompt. This will send a request to the server, which will generate code and will return to us several files for simulation. You can browse through the files in the newly created folder with your controller's name. The Forces Pro block will now be prepared so that it can be directly integrated into your Simulink diagram. It is that easy. Now I can just run the simulation and observe the inputs and outputs of the system. We see how the actuator constraints are always satisfied. On the output side, we see how the pitch angle reference is accurately tracked while the aircraft is being operated at the maximum angle of attack position most of the time, but never exceeding it. Once I am happy with the controller response, I can go to the solver settings and enter the details of my target embedded platform and play around with different solver settings. In this case, I am going to request single precision code. I will use an interior point method, and I want to target an ARM Cortex-M4 microcontroller with a floating point unit. Now, when I type configure block again, I get customized code for that particular embedded platform. I get object code to link to my ARM project, and if I had the premium version of Forces Pro, I would also get source code. This demo has shown some of the capabilities of Forces Pro and how you can use it to quickly generate state-of-the-art customized optimization routines for your advanced optimal controllers. Register at embotech.com to download a free trial now.